Hello everyone, this is a demonstration video for our shaft straightening hydraulic press machine. We have designed and manufactured this hydraulic press for the special purpose of straightening any kind of cylindrical shaft which is required to maintain uniform cylindricity throughout its length. Here, the application of our machine is to straighten and clear runouts in our workpieces, which are IC engine camshafts. During the manufacturing processes, the camshafts acquire bends and runouts when they go through heat treatment. These bends are unacceptable during the following processes like precision grinding, which result in rejection of the parts. So, to straighten these shafts to the prescribed limits, we use our hydraulic press. The basic structure of our machine consists of a fabricated steel C-frame with a longitudinal bed to carry the shaft. The hydraulic cylinder at the center can apply a force of up to 200 tons. To hold the camshaft, we use two dead centers with hydraulic clamping which can hold the camshaft between centers. And the shaft can be moved horizontally along the axis so that a specific point can be pressed. The sliding assembly uses linear motion guideways to move the centers. During the pressing operation, the camshaft is supported by a V-block assembly which can be adjusted for a certain height and can slide along the length of the shaft to any required point. The centers can be adjusted to carry a wide variety of shafts of various lengths, diameters, and weight. To measure the runout, a dial indicator is provided which can also slide along the length of the shaft. All the operations are achieved through electronic control panel. The hydraulic power pack unit is contained within the machine body. All the hydraulic pressures are indicated through gauges. A water-cooled heat exchanger is also provided to prevent the system from overheating, which enables it to work over longer duration without breaks. All the assemblies are designed to provide high reliability and accuracy. The frame is built heavy to endure all the pressing force and have a long life. We have designed the operating system to be safe and easy to use. The operation is as follows. First, we set the distance between the centers suitable for the length of the shaft by adjusting the guide rods. Then we set the V-blocks to a suitable height so as to keep the shaft suspended. The next step is to clamp the shaft. The shaft is clamped into position just by placing it on the V-blocks and then pressing the clamp button on the panel. The clamping cylinder extends to lock the shaft in position. The same is done to declamp and release the shaft from the holding position. The clamping force can be adjusted for shafts of different weights using valves and gauges on the panel. Here we can observe that when the shaft is clamped and held between the centers, the job is free and easy to rotate so that inspection and measurements can be carried out and marked along the length of the shaft. Measurement of runout is done with a dial indicator manually, and the position is marked by the operator. Here we can observe the magnitude of the runout on the center journal. Once the bends are identified and marked, the V-blocks are moved into the suitable positions and the shaft is moved along the axis so that the bend is directly under the pressing head. Here we can see that during the inspection the shaft is suspended above the blocks. When the pressing starts, the shaft is first rested on the V-blocks and then the pressing force is applied which further deforms the shaft. After the desired pressing, the ram is retracted and the shaft is again suspended in a floating position. The pressing force can be adjusted as required and the mode of retention can also be selected using the switch on the panel. The machine can be set to coarse and fine modes. The position and intensity of bending is determined by the operator. The shaft carriage mechanism and the movable V-blocks allow the machine to reach any position from one end to the other with ease. Here the operator carries out and repeats a continuous cycle of pressing and checking until the shaft is straightened within prescribed tolerances. Here we can observe the corrected runout of the central journal of the shaft. Finally, when the operation is completed, the shaft is declamped and removed from the bed and is replaced with the next job seamlessly. Our machine is designed to reduce the motion and effort required to switch between the pressing and checking cycles. This results in lesser time consumption and increase in productivity. The setting time required is very less due to the exclusive mechanical nature as compared to numerically controlled machine. In addition to all the above advantages, our machine is easily able to accommodate a huge variety of different shaft designs in its variable center height mechanism. This concludes the demonstration. Please feel free to contact us for any question or inquiries. Thanks for watching.